This is a short video on simplifying expressions by combining like terms. So I have 4 problems here that I will review, and then you can continue and do the practice problems. Let's move on to question 3. Once again, we're looking to identify our like terms. xy and xy. The 2 and the 3 in front of it does not matter. Those are like terms that can be combined. And once again, we have a plus 5 at the end here. That's different. So we can combine the 2xy and the 3xy, and we're just counting the number of xy's that we have. We have 2 here, and we have 3 more. That gives us a total of 5 xy's. And then we have to add 5 at the end because we have nothing else that we can combine that plus 5 with. Our answer would be 5xy plus 5. Let's move on to the last question, number 4. What's different about this one is that we've got things a little bit mixed up here. We have an x term, a constant, another x term, and another constant. So let's identify our like terms, this x term and this x term. Remembering when there's no number in front of it, we can think of there as being the 1. And then we have plus 5. I like to include that sign, and minus 1. That helps us keep track when we combine them. Let's combine the x's. 1x and 2x give us a total of 3 x's. Positive 5 and negative 1. That's going to be like 5 minus 1. We're going to end up with positive 4 when we combine those two. 3x plus 4. So hopefully that was a short but helpful introduction to combining like terms. So take a look at the 10 practice problems that follow. And if you need to do this again, come back and take a look at this video and try those 10 problems again and see if you do better the second time. Good luck. In this video, we're going to talk about how to subtract polynomials. So we have an example up here on the screen. And the big thing to remember here is that when we're subtracting these two polynomials, we are subtracting this whole second part here. All of the pieces of that need to be subtracted from the first. So what we want to do is rewrite the first. It's always a good strategy for a problem like this to rewrite it. We rewrite the first without the parentheses, but then for the subtraction of the second polynomial, if we're subtracting, we're going to change the sign of all of the terms on the inside of the parentheses. So the sign of this first term is positive. We can't quite see it, but because it doesn't have a negative in front of it, we know that it's a positive. So we are going to change the sign of that and treat that as subtraction. So that's going to become minus 4x. And then we change the sign of this second term. The second term is minus 2. That's going to become plus 2. That's all there is to it. We just need to remember to change those two signs, and then we can drop the parentheses, and then we can treat this like any problem involving the combination of like terms. That is the trickiest part of a problem like this, remembering to change the sign of everything that's in those parentheses. Let's try a few problems. All right, number 1 here. Let's identify our like terms. We've got 10x, we have 5x, we have plus 5, and we have plus 2. So those are going to be our like terms. So we can rewrite the first part, 10x plus 5. And then for the next part, we're going to remember to change the sign because we are subtracting this polynomial. So plus 5x is going to become minus 5x. Plus 2 is going to become minus 2. And now it's just a problem involving the combination of those like terms. We already said that these were our like terms, 10x and minus 5x. Those will combine to give us 10 minus 5 is 5. And then we have plus 5 and minus 2. 5 minus 2 is positive 3 plus 3. That would be our answer to question number 1. So let's practice that process of changing the sign. I'm going to use this negative sign to change the sign of that and to change the sign of that. And we would do this no matter how many parts there are, how many terms are in those parentheses. So we can rewrite the first part, 3ab. And this is where you want to take the advantage of the opportunity to write when you're taking the test. Use the whiteboard. Minus, this is a positive 6ab, becomes minus 6ab because we're subtracting it. Now we're subtracting positive 2b. It's going to become minus 2b. Let's identify our like terms. Use a different color for this. 3ab and minus 6ab. 3 minus 6 minus 3ab. Our next set of like terms are plus 10b and minus 2b. 10 minus 2 leaves us with plus 8b. This video and related practice questions is on the subject of multiplying monomials. Let's first talk a little bit about what a monomial is. A monomial is just a term. We've been dealing with polynomials where we had like 2x plus 6x plus 3, maybe something like that. And those are each terms. Those are each monomials. So in this video, we're going to be talking about multiplying those terms together instead of adding and subtracting them, as we've been doing in the previous videos. So let me erase that. Here's an example up here of the multiplication of two monomials. We're multiplying 2x and 6x. That's actually one of the examples I will be covering in a few minutes. So there are two main steps to multiplying monomials. First of all, multiply the coefficients. The coefficients are the numbers in front of the variables. So in this case, we have a coefficient of 2 in front of this x and a coefficient of 6 in front of that x. So as I said, we will be doing that problem in a few moments. The second step is to add the exponents for each variable to get the new exponent for that variable. So in this case, we will look at our two variables and we'll notice that there aren't any exponents. When there aren't any exponents, you need to remember that there is actually an exponent of 1. So that will be very helpful for working through these problems and getting them correct. Remembering when the variable does not have an exponent, it really has an exponent of 1. Hopefully that makes sense. Let's move on to question 3. Now this one's a little bit different because we actually have two different variables. We have a y and we have an x. And we don't have any other y's or x's that are being multiplied together. So what's interesting about this problem is that we don't really have anything to do other than to rewrite this as 5 times x times y. Now, why did I write it in that order? Well, normally we write the number first, the coefficient, or the product of the coefficients will be first, and then the variables will appear in alphabetical order. So 5 times x times y. It just ended up being kind of a rearrangement of those terms. Okay, let's look at number 4. We have coefficients. We have a variable of x to the second power. We have a coefficient of 5 and x to the fourth power. Let's do the rearranging thing and put the coefficients together. 2 times 5. And then I'm going to do x squared times x to the fourth. So all I'm doing there is grouping it the way that I want to do the multiplication. We multiply these two coefficients. 2 times 5 is 10. Be careful when there's a negative number there. It's just like multiplying any negative numbers, but you want to make sure that you get that right. And then when we multiply x times x, we are going to add those two exponents. So we could say that that's going to be x to the 2 plus 4. Don't make the mistake of multiplying those exponents. That's the most common mistake that you would make. That might seem like the right thing to do because we're multiplying, but we have to add them to get the correct answer. So 10 times x to the 6th. 10 times x to the 6th would be the correct answer for that question. This is the first of 2 videos on multiplying polynomials. An example is shown on the screen right now. 7x times, in parentheses, 2x plus 3. So let's take a look at the steps of multiplying a monomial and a polynomial, which is what we see down below. The monomial is the red 5x, and the polynomial is 3x plus 2, the part that's in the parenthesis. So the trick to doing these problems is that we need to remember that we are going to multiply this times 3x, but we're also going to multiply it by 2. And we're going to add the results of those two products together. So let's take a look at what that looks like. That would be like multiplying 5x times 3x and then adding the product of 5x and 2. This is a great way to break down this problem into a way that's more manageable. Now we're just taking the product of these two monomials and we're adding it to the product of these two monomials. Let's take a look at some sample problems. All right, problem 3. We're going to multiply 5x times 2x and 5x times a negative 3 in this case. Once again, I am always going to treat this as addition. So I'm going to set up this form for a problem like this. We are going to have two products and we're going to add them together. So in this first one, first product, it's going to be 5x and 2x. In the second one, 5x and minus 3, negative 3. Okay, so let's do these products. 5x times 2x, 5 times 2 is 10, x times x, x squared, x to the second power. 5x, I'm going to still treat this as addition, and because we have a negative in this second part, I'm going to first make a parenthesis here, and I'm going to put our result in the parenthesis. 5x times minus 3. 5 times minus 3, minus 15. And there's just an x. There's not another x to multiply it by, so it's just minus 15x. Now, this is what I'm talking about in terms of letting the sign of this second part determine whether this is addition or subtraction. Adding a negative number is the same thing as subtracting. So we can now rewrite this as 10x squared minus 15x. In this video, I'm going to review the basics of dividing polynomials, focusing on dividing monomials. For example, the problem that's shown at the bottom of the screen right now. That looks pretty nasty, but when you understand how to do it, they're really pretty simple. Let's take a look at the steps to dividing monomials. It's basically the opposite of multiplication. So when we multiplied monomials, we multiplied the coefficients and we added the exponents of the variables. When we divide polynomials, we are going to divide the coefficients. Those are the numbers before the variables. So in this case, 6 on the top of the fraction and 2 on the bottom of the fraction. So as shown here, we're going to divide 6 by 2 and we get 3. That's the first part of the work that we need to do in this problem. If you don't get a number when you divide it, you can just reduce the fraction. For instance, if this had been 6/4, that would have reduced to 3/2. And you would want to do that. You want to reduce the fraction that's created by the coefficients. So either divide or reduce the fraction. In some cases, you won't be able to do either, but that's okay. You still need to attempt to do that. Then let's move on to the variables. So here we line up. Let me erase this and focus on our x's now. We have x to the 6th over x to the 5th. So we kind of set up that fraction and we subtract the exponents. We subtract the bottom from the top. So it's going to be x to the 6 minus 5, or x to the 1st, which we normally just write as x. Moving on to y. We have y to the 3rd over y. We set up that fraction, y to the 3rd over y. That becomes y to the 3 minus 1, remembering that when there is no exponent, there really is an exponent of 1. We subtract those two, and we are left with y squared. So we put together our answer at the end here, 3 times x times y squared. And that's our answer. And once you get good at these, you're going to look at this problem over here, and you are almost immediately going to see that answer. You won't have to quite work it out in all of these details, but that takes some practice. So let's get to a few practice questions. Here we have 2 different variables. So we start out with the 7. And we're trying to deal with our coefficients. And we notice that, well, we don't have a coefficient on the bottom. But remember that there's always a coefficient of 1. So it's really just 7 divided by 1, which is just 7. Then we have x to the 5th divided by x to the 4th. 5 minus 4 is 1. That's just x. And then we have y to the 4th divided by y to the 4th. Well, this one might be confusing because 4 minus 4 is 0. What does that mean? Well, remember that anything divided by itself is just the number 1. And we could write 7 times x times 1, but normally we don't write that 1, and our answer would just be 7x. Now, a common way to think about this is to just cancel out the y to the 4. Whenever you see a variable with the same exponent on the top and the bottom, you can just ignore them. They are going to cancel each other out. So that allows you to just deal with the rest of the problem. All right, let's move on to problem 4. We have our coefficients of 10 and 2. Let's try to divide that. 10 divided by 2 is 5. So it looks like 5 will be the coefficient of our answer. A to the 5th divided by a to the 2nd. 5 minus 2 is 3. That leaves us with a to the 3rd. B to the 4th divided by b to the 4th. This is the situation that we just had over in problem 3. We can just cancel those out and ignore that part. And here's a situation we haven't run into so far in these problems. We just have the variable c, and it's on the top of our fraction. We're not dividing it by anything. There's no c on the bottom, so that will just carry through to our answer. There's nothing we can do with that c. So our answer to this problem becomes 5 times a to the 3rd power times c. All right, that wraps up this video on dividing monomials. The next video will cover dividing relatively simple polynomials. In this video, we're going to be reviewing evaluating expressions with variables. There's an example at the bottom of the screen here, 5xy plus 7y, when x is equal to 2 and y is equal to -3. So if we know the values of x and y, we can figure out the value of this expression by substituting for those variables. So let's take a look at some steps. We have another example here. What is 3xy minus 6y plus x when x is equal to 2 and y is equal to -3? Let's take a look at the steps. Carefully replace each variable with the given number for that variable. So in this instance, we're told that x is 2, so we can replace x with 2. And we have another x here. I'll explain why I'm wrapping that in a parenthesis in a moment. Y is equal to -3. And here's another y, -3. So that's effectively our substitution. We could rewrite this whole thing, and we'll go through some examples of doing that in a moment. I suggest wrapping the negative values in parentheses. Actually, wrapping all of the substituted values with parentheses is a good idea. It just helps keep track of those substitutions and avoid mistakes. After that, you want to follow your order of operations rules. In other words, PEMDAS. So where we do the parentheses and then the exponents, then multiplication and division, and then addition and subtraction. Use your calculator if possible. If you are allowed, you're going to make less mistakes if you do that. Let's take a look at some examples. Here's the first one. 2 times x plus 3 times y minus 4z. When x is equal to 3, y is equal to 2, and z is equal to 0. So when I'm rewriting this, I'm going to write it like this. I'm substituting 3 for x. Then we have addition. We're multiplying 3 times y, which is 2. And then we're multiplying 4 times z, which is 0. When I'm adding things together like this, I can evaluate each part separately. I'm going to do this multiplication first because that's what PEMDAS tells us to do. 2 times 3 is 6. 3 times 2 is also 6. And we're subtracting 4 times 0. Well, 4 times 0 is just 0. So we could say we're subtracting 0 or just leave that off. And we're left with 6 plus 6. So the answer to this question would be 12. And this might be an example of a problem where you would be asked to do this without a calculator because the math is pretty straightforward. In this video, we are going to talk about doing problems that involve the concept of absolute value. Let's review what absolute value, or sometimes it's called absolute change, means. It's the amount of change in something without a negative sign. In other words, we're not really concerned about the direction. We're just concerned about the amount of the change, and we will treat it as a positive number. So there are absolute value symbols that we will review in a moment. If the result of what's in the absolute value symbols results in a negative, we're just going to ignore that negative sign and treat it as positive. The symbol for absolute value is two vertical lines. They look like this. They act as parentheses, but they have the extra effect of turning the result of whatever is inside positive. So I'm not going to go through all of these examples, but if we look at this as a parenthesis, we're going to do the math inside the two symbols. If it turns out to be a negative number, we will turn it into a positive number and then continue with the math. The rules of working with absolute value symbols. Here's an example right here, 5 minus, and then we have our absolute value symbols, 7 times in parentheses, regular parentheses, 1 minus 2. First, we want to treat the absolute value symbols like parentheses. So we will do everything inside of that first. So let's do that with this little example here. So within our absolute value, we also have parentheses. So we have to do that first. So our first step of simplification might look like this. 5 minus the absolute value of 7 times 1 minus 2 is minus 1. So inside our absolute value, we have 7 times minus 1. So now let's do that multiplication. That gives us 5 minus absolute value of negative 7. Now here's where the absolute value comes into play. This is going to turn this into a positive 7, but we're still subtracting it. So it's going to be 5 minus a positive 7. See how we've dropped the absolute value symbols, and we've turned this 7 into a positive number. This subtraction comes from here. A positive 7 comes from there. And now we just simplify normally. That's going to be the next step. And so the sign of the result of our absolute value was negative 7. We ignored that. We made it positive 7. And then finally, we continue with the rest of the simplification. Normally, that gives us a result of negative 2. 5 minus 7 is negative 2.